Okay, so I had seen a video and I'm going to splice all that in, but I want to put all this together so nobody thinks I'm doing anything shady or whatever. All right, so here we go. Question: Can you do math in perspective?
Yes, I can help with both math and perspective. Whether you need assistance with mathematical problems or need help understanding or describing something from a particular viewpoint, feel free to provide the details, and I'll be happy to assist.
How many miles does a human have to be above the ground to look with their own eyes and see the entirety of the Earth? Show your math and explain the solution, please.
To determine how high a person must be to see the entire Earth, we need to find the altitude where the entire Earth's surface becomes visible. This involves some geometric considerations involving the Earth's radius and the person's line of sight. The Earth can be approximated as a sphere with a radius r of approximately 3,959 miles, 6,371 kilometers. If a person is at an altitude, h, above the Earth's surface, the distance from the person to the horizon can be calculated using the geometry of a circle. Here's a step-by-step solution. 1. Geometry of the problem. The person is at an altitude h. The Earth's radius is r. The line of sight from the person to the farthest visible point on the Earth's surface forms a tangent to the Earth's surface. 2. Formula for the line of sight distance to the horizon. The distance, d, to the horizon from a height, h, can be found using the Pythagorean theorem in the right triangle formed by the Earth's radius, the radius plus the height, and the distance to the horizon. R plus h to r squared plus d to 2. Solving for d equals r plus h cubed minus r2 equals r2 plus 2rh plus h cubed minus r2 equals 2rh plus h squared. 3. Seeing the entire Earth. To see the entire Earth, the person must be at an altitude where their line of sight reaches the opposite side of the Earth. This means the distance, d, must be at least equal to the Earth's circumference, c. The circumference of the Earth is c equals 2 pi r. 4. Setting the line of sight distance equal to the circumference, squirt 2rh plus h squared, g 2 pi r. 5. Solving for h, square both sides to eliminate the square root. 2rh plus h2 equals 2 pi r squared. 2rh plus h squared equals 4 pi squared r squared. Rearrange to form a quadratic equation. H squared plus 2r minus 4 pi squared r squared equals 0. Solve the quadratic equation using the quadratic formula. H equals frac minus b minus 4ac2a, where a equals 1, b equals 2r, and c equals 9 of 4 pi squared r2. H equals frac 9 of 2r2 minus 1 minus 4r squared r2, 1. H equals frac 9 of 2r squared 4r2 plus 16 pi squared r2. H equals frac 9 of 2r, 4r2 1 plus 4 pi 2. H equals frac 9 is 2r 1 plus 4 pi 2. H equals 9 is r plus 4 pi squared. Since height h cannot be negative, we take the positive root. H equals r 1 plus 4 pi squared minus 1. 6. Substitute the value of r. R equals 3,959. H equals 3,959. Square 1 plus 4 pi squared minus 1. Calculate the value. H equals 3,959 plus 4, 9.8696 minus 1. H equals 3,959, square 1 plus 39.47 minus 1. H equals 3,040.4784 H equals 3,959, 6.361 minus 1. H equals 3,959 times 5.361. H approx 21,224 miles. Therefore, a person would need to be approximately 21,224 miles above the Earth's surface to see the entire Earth with their own eyes.
Okay. What is the height of the space station?
The International Space Station, ISS, orbits the Earth at an average altitude of approximately 420 kilometers, about 261 miles, above the Earth's surface. This altitude can vary slightly due to orbital adjustments, atmospheric drag, and other factors, but it typically stays within the range of 408 to 420 kilometers, about 253 to 261 miles.
So the space station would have to be about 21,224 miles above the Earth to see the whole shape of the Earth?
Yes, that's correct. The ISS orbits at an altitude of about 261 miles, which is far too low to see the entire Earth at once. To see the entire shape of the Earth in one view, an observer would indeed need to be at an altitude of approximately 21,224 miles above the Earth's surface. This altitude is far beyond the orbit of the ISS and is more in line with the altitude of geostationary satellites, which orbit at approximately 22,236 miles, 35,786 kilometers above the Earth. From such an altitude, the entire Earth would be visible as a single sphere, similar to the famous blue marble photograph taken by the Apollo 17 astronauts.
So, would it be fair to say that in comparison, 261 miles would be the equivalent of having your nose up against the wall while trying to see the whole of it? Like if you made the space station your nose and the Earth the wall?
That's a fair analogy. At an altitude of 261 miles, the ISS is much closer to the Earth's surface relative to its size, similar to having your nose close to a wall and trying to see the entire wall. Just as you can't see the entire wall when your nose is right up against it, the ISS cannot see the entire Earth due to its proximity. Here's why the analogy works. 1. Proximity. When you are very close to a wall, your field of view is limited to a small area directly in front of you. Similarly, the ISS, being only 261 miles above the Earth's surface, can only see a small portion of the Earth at a time. 2. Field of view. From a close distance, the curvature of the Earth isn't apparent, and the horizon is relatively near. The ISS's field of view covers a large area compared to human scales, but still only a fraction of the Earth's surface. 3. Perspective. Just as moving far away from a wall allows you to see more of it at once, moving far away from the Earth to the altitude of geostationary satellites or beyond allows you to see the entire Earth as a complete sphere. In summary, yes, the analogy holds. The ISS is close enough to the Earth that it can only view part of it at a time, much like being close to a wall limits your ability to see the entire wall.
Ugh, it's 7:30 in the morning right now. I've been up for about an hour. It's too early for this shit, but I don't know if the earth is flat or not 100%. What I do know is NASA's full of shit and they're definitely bilking people for money and this story is not accurate.